Okay, so the next topic we're gonna go on to is we're gonna review the scientific method, right? You guys know this before, but we'll just briefly go over how it is that we're amassing knowledge. What is the system we use in order to reliably um, accumulate knowledge and be confident, right, in the knowledge that we accumulate. um, what is that method, right? So it's called the scientific method, and the approach is based on just observation and experimentation, but rigorous experimentation to make sure that we are kind of come up with the right conclusions, right? So observation, then experiment, and after rigorous experimentation, we can sum up and formulate what we call laws and theories, right? So in order to get experimentation, we have to formulate a hypothesis. And let's go through each key points here of the scientific method. So first we have observations, right? So observations are just facts, just straight up facts, just data, right? There are no conjecture, nothing. It's just very dry data, right? So for example, something like my shirt is red. Okay, that's an observation. Um, right? No conjecture needed. It's just fact. Okay. So they tend to be descriptions about um nature, right? Descriptions about the characteristics or behavior of nature. So an example, back in the day, Antoine Lavoisier in the 1700s noticed that there was no change in the total mass of a material within the container during combustion. So after an observation like that, Lavoisier's, um, you know, thinking, wait, why is that, right? Why am I observing that? And so then he formulates a hypothesis, right? So after observing, you form a hypothesis to tentatively explain the observations, right? Um, and you may not, know it for sure, but it's an educated guess, right? To try and explain what you're seeing. So, for example, Lavoisier explained his observations on combustion by hypothesizing that when a substance burns, it combines with a component of air. Now, a good hypothesis has to be falsifiable, right? So that what falsifiable means is that it can be proven right or wrong. Okay. Um, there must be a way to test whether the hypothesis is good or not, right? Um, so that's the key point, right? The hypothesis, it must be falsifiable. So the results of an experiment may support a hypothesis and prove it wrong, in which case you're gonna have to throw it out or you're gonna have to modify it, right? Okay, and then what is a scientific law? So now, after you have the hypothesis, you do a lot of experimentation to try and prove that hypothesis, right? And after rigorous experimentation, if you see whatever the result is that keeps coming up, what you can do is you can summarize, right? The results, um, and you can make it into a law, right? Just the summary of observations and results. So, for example, the law of conservation of mass is in a chemical reaction, matter is neither created nor destroyed, right? So it's a brief statement that summarizes, results um, from past experimentations, and it is can be used to predict future ones, right? So now, not just in this chemical reaction, matter is neither created nor destroyed, but I know that in every single chemical reaction in the future, regardless of what I'm trying to make, that has to hold true, right? That's the law. And unlike, civil laws or governmental laws, scientific law cannot be broken, right? And so that's why we call it a law, right? It is that robust. So it allows you to predict future observations, right? That's pretty cool. You can also test law with experiments, right? And that's how laws become so so strong, right? So robust is you keep testing a law with further experiments, right? Okay, then we get to theory, right? So how a theory is basically one or more well-established hypotheses. And it's formed also from rigorous experimentation. And the way it's different than a law is that the scientific theory tells you why. It doesn't just tell you the what of nature, but it will try to explain the why. Okay. So that's the difference, right? The law will tell you the what of nature, but the theory will go one step further and tell you why it is that way. Okay. So theories are very um, powerful, right? Because if you know why, you can design, right? Um, you have much more control if you know why things occur rather than just what will happen, right? So theories can never be conclusively proven because some new observation or experiment always has potential to reveal a flaw, right? So theories are basically approximations of the truth, and we know that theories are not perfect, right? We will get to a point where, it is pretty robust and we know we can rely on it, but we are also, humble, right? We're not going to say that we know it all. And that is what science is all about, right? And a new experiment could potentially reveal a flaw, and then you refine the theory, right? And you keep doing that, and you keep refining the theory until it is the strongest that it can be. Right? So the theory, one of the theories that we're gonna dive into is, Dalton's atomic theory, right? What is because we can't observe the atom straight on, right? And so, what is the theory of the atom? What does it actually look like, right? We it is a theory because we actually don't know for sure, right? We have of course a great idea, and it works for us, right? Dalton's atomic theory works, but um, yeah, we can't see it, so we can't say that it's 100% true, right? So theory, like laws, can also be used to predict future observations, right? But remember, it's also going to explain the why, right? Not just what will happen. Okay, so here's a diagram of the summary of the whole scientific approach to knowledge, right? You can see that there's a lot of like circles, right? And that's because that's the whole premise of what the scientific approach is. We never say that we know everything to 100% certainty, right? And so we can always test and confirm, right? And that will just refine the theory and the law and make it stronger, right? Um, or if we reveal a flaw, we can throw something out, right? And so we're always trying to, test, just do lots of tests, lots of experiments, and make sure that we can confirm the theory and refine it further, right? And it's the same thing with the law, right? The law there, you can also see, you can keep testing to make sure that the law is also the best that it can be, right? So the idea here is just lots of experiments to confirm, even things that we think we know for sure, right? We keep testing. Okay, so here's your first conceptual check. Which statement best explains the difference between a law and a theory? Okay, so you guys may want to pause the video at this point. You're going to answer A, B, or C. All right. Okay, so the answer is B. A law summarizes a series of related observations. A theory gives the underlying reasons for them, right? So same thing as saying, okay, the law tells you what will happen, right? The theory will give you the reason why, okay? So in that way, I feel like a theory